Hi, my name's Stewart Lynch. In this video, I want to show you how you can convert any vector SVG file into a BezierPath and add and animate it to your SwiftUI projects. If this is something you want to learn, then keep watching. I recently subscribed to Paul Hudson's Hacking with SwiftPlus. If you're not familiar with Hacking with Swift and Two Straws, then you're missing out. He is undisputably the king of Swift and SwiftUI content creation, and I am pleased to be able to support his efforts and to gain his wisdom in his free posts and also those for subscribers on Hacking with SwiftPlus. Anyway, one of the first posts as Hacking with SwiftPlus was released was creating a shape view to render UIBezierPaths. In this article and video, he walks us through making a simple SwiftUI shape view struct to draw any kind of UIBezierPath into a Swift view hierarchy. I thought this was brilliant, and I had just received my new logo designed for my company. It's more complex, however, and it has multiple paths, and the method that Paul shared just didn't work. Now, I'm not a designer, but the Fiverr.com website is a great place to find designers who are willing to do that for you at a very reasonable price. I found a Canadian designer who goes by the profile Creative Notion who created this one for me, and I'm very pleased. I'll leave a link to his profile in the notes below. Anyway, what he sent me was this design in a number of different formats, and one of them happened to be an SVG, which is the vector graphics format. So SVG is a scalable vector graphics that defines vector-based graphics in an XML format. So I can open this in my text editor of choice, which happens to be Sublime Text, and I can see a number of paths in the XML file, but these aren't Bezier paths, so I'll need to convert them somehow. But before I attempt that, I'm going to open this in my graphics editor, which is Sketch, and all I really want is this logo portion. So let me copy and paste it elsewhere onto my canvas in Sketch, and I'll make an artboard, and I'll make it exportable, and I'll export it as an SVG. Now if I open this file in Sublime Text, I see that there are two paths, and I also get the hex colors that were used on the paths. And this is great. I'll come back to this later, but first let's create a new SwiftUI project, and I'm going to call mine SVG to Bezier for lack of a better name. Now the first thing I'm going to do is copy over two extensions that I've created, one for UI color and the other for UIBezierPath, and these files are in the resources folder referenced in the link in the notes below. The UI color extension has a static function that accepts a hex string with or without the #, and an optional alpha value, and it returns a UI color. The UIBezierPath extension also has a static function that accepts an array of UIBezierPaths and returns a CGRect, which is the bounds for the combined array of paths that were passed in. Now this is important for us because the artwork may be multiple paths, as you saw mine was, and we need to know the total image bounds in order to scale our vector graphic properly. So first, let's create a new Swift file called ShapeView that will contain a struct for composing our shape. Let's change the import to SwiftUI, and we'll create that struct called ShapeView that conforms to the shape protocol. Now most of what you're going to see here is exactly what Paul goes through in his article, but the difference is that the BezierPath's points go from between 0 and 1 on both the X and Y axes, and you'll see that when we convert our SVG path to Bezier, we got whatever the values were provided by the XML. So in order to conform to shape, we need a single function called path that accepts a CGRect, which is the container where our shape will be drawn, and it returns a path which will be our shape. Now, we want to initialize this struct with a BezierPath, but because our BezierPath might be part of a larger group of BezierPaths, we need to know the greater bounds as well. So we'll introduce two variables, Bezier, which is a UIBezierPath, and pathBounds, which is a CGRect. The first thing we're going to do for our path is to scale down our points to between 0 and 1. And to do this, we'll need to know the dimensions of the rectangle we are in and the bounds of the entire Bezier. If we know that, we can create a scale factor. So if the containing rectangle's width is greater than or equal to the height, we'll set the scale to be the maximum of the path bounds, width and height. Otherwise, we'll set it to the minimum. Next, we create a scale transformation where we can set that to a CG affine transform where the scale x and y are both the inverse of our point scale. And finally, at least for this transformation, we can apply the Bezier path that we have passed in. The next transformation is what Paul described in his tutorial. We want to ensure that the path will fit inside the rectangle that our shape is contained in, so we'll find the minimum of the rectangle's width and height, and this will ensure that our shape doesn't exceed the bounds of the containing rectangle. So we'll let the multiplier be the minimum of the width and height. Then we'll create another CG affine transform that will scale x and y by that multiplier. And finally, we can return our path applying that transformation. Great, now all we need is our Bezier paths. So let's go back to our text representation of our logo, and I'll copy the content of the D attribute of our first path. And with that copied, I'll need to convert it to the Bezier path. Well, luckily for us, there's a website that will do that for us, and I'll leave a link in the notes below. All I have to do is paste that copied path into the top frame, and it is immediately converted and displayed in the lower frame. So I can copy that conversion to my clipboard, and I'll go to my UIBezierPath extension. Within that extension, I'll create a static computed variable that I'll call CTLogo1 of type UIBezierPath, and I'll paste the contents of my clipboard into the body between the braces, and at the end, make sure I return the shape, which is the required UIBezierPath. So I'll repeat that for my second part. Copy the D attribute, paste it into my converter, and copy the conversion. Create a new static var in our UIBezierPath extension, and I'll call it CTLogo2. Then I'll paste in the conversion and return the shape. Well, now we can use it. Inside my content view, I'm going to create a variable for our path bounds. And for this, I'm going to use the static function in my UIBezierPath extension to merge the two and assign it the CGRect bounds. The array of UIBeziers are just .CTLogo1 and .CTLogo2. And that's the advantage of adding these two static variables as properties of the UIBezierPath extension. So I can now replace my hello world with a shape view. So let's start with initializing it with CTLogo1 and make sure that we also pass in the path bounds. Right away, our canvas is showing that portion of our logo. But I have two shape views, so I want to use a stack view so that they'll appear on top of each other. So I'll embed this shape view in a Z-stack. I'll just copy and paste the shape view and change the Bezier to CTLogo2. Now it's being displayed as the entire width of the device, which is the minimum width and height of the containing content view. Let's reduce the frame to, say, 200 by 200. Well, this is better, but you can see that our logo isn't centered within the frame. In fact, if we change the frame to width of 300, it becomes even more obvious. So we can fix that by setting our frame's height to be the width, but multiplied by the ratio of our bounds. Perfect. Now let's add some color and an outline using the colors we have. You may recall that the SVG file uses hex values for color, so we can use the UI color extension provided to define our colors as UI color from hex string function. And we'll just pass in the hex string with or without the pound sign. And we can get these from our SVG file. Now let me do the same for our second color. Next, let's add a stroke modifier to each shape view that uses the corresponding color and has a line width of 2. Now we'd like to animate when that Z stack or that Z stack appears. So on the Z stack we'll use the .onAppear function and we'll trigger an explicit animation with a ease in out with a duration of 2 seconds. Now what we want to do is animate the drawing of this shape so that we can animate that by trimming the path. So let's create an @state variable called endAmount that starts at 0, which means when it's trimmed, no path will be displayed. And then our animation block will set the endAmount to be 1 so that over 2 seconds the trim will gradually change so that the entire path will be displayed. So now we can apply that trim to both shape views going from 0 to the endAmount. As we preview this on our canvas, we see it in action. Now finally, we want to fade in a solid shape after the outline is drawn. What we do is gradually fade in 2 more shapes right on top of these 2. So let's duplicate these 2 shapes, but remove the 2 modifiers. And I'll replace the modifier with a fill color corresponding to the color of that portion of our shape. Now we need to delay the start of this animation for 2 seconds. So let's create another ease in out animation of 2 seconds with that 2-second delay. Now when the view appears, we want the opacity of these 2 shapes to be 0, and then gradually over 2 seconds become 1. To accomplish this, we'll create another @state variable. And we'll set that to be true in our animation block. And we'll use that to determine the opacity, where if isFilled is true, the opacity is 1, else it's 0. Let's test. This is so cool. Now I know this has been a long video, but with these 3 files, the shape view and the 2 extensions, you can quickly add and animate shapes from other SVG images. For example, just to finish up, let's just look at one more example. I found this SwiftUI logo SVG on the web. And when I open the SVG in our text editor, I can see that there is only one path. So I'm going to copy and paste that into our converter. And I'll return to our UIBezierPath extension and create a new static variable called SwiftLogo. I'm going to return to Content View, and since our shape only has a single path, I'll remove the second shape path from our Z stack. Now let's return to the SVG file, and I'll see that there are two colors. So I'll replace the colors in our Content View with these colors. Now our path bounds is only one path, which is just .swift logo. Our shape view's BezierPath is that same Swift logo, and I'll change the stroke color to be the first color and the fill to be the second. This looks pretty good, but you may recall that the actual Swift logo is not a solid color, but rather a gradient. Well, we can fix that. We can change our fill to be a linear gradient that uses our two colors, and it starts at the top leading, the top left, and ends at the bottom trailing, or bottom right. And we have to make sure, of course, that the opacity changes with the animation. And now, just to add a little bit more oomph, I'd like to rotate this logo once it's filled. So to do this, I'll add a new @state variable that I'll call scale, and I'll set its initial value to 360 degrees. And with that, I can apply a 3D effect to the Z stack that will eventually animate around the Y-axis. And the animation will go from 360 to 0, which is our scale factor, causing a clockwise rotation. Now we can just add one more with animation right here after the last one, and a delay of 4 seconds afterwards so that it doesn't start until after the fade in has completed. So I'll use a linear animation this time with a duration of 4 seconds that will repeat forever, and set auto reverse to false, making sure that we have that delay of 4 seconds. And in the body, I'll set the scale to 0, and that will rotate the logo. So for a change this time, let me run it in the simulator in dark mode. Now, wasn't that easy? I hope you can use this technique in your own projects. I have lots of other videos available and in the queue as well, so please check out the rest of my channel. You can also visit my website to see the apps that I have available on the App Store, and visit my GitHub page to see what I have available as public repositories. If you like what you've seen, give it a thumbs up and subscribe to my channel. And ring the bell to get notified when I post new videos. I'm most active on Twitter, so please follow me there as well to find out what else I'm up to. Thanks for watching.